Sysdig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using Sysdig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. Sysdig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using Sysdig. To learn more, visit securityweekly.com/Sysdig.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella.
Howdy.
Some of you told us that you are overwhelmed by the amount of content we distribute. In an attempt to make it a little easier for you to find what you're interested in, we've created our new listener interest list. Sign up for the list and select your interests by visiting securityweekly.com/subscribe and clicking the button to join the list. You can also now submit your suggestions for guests in our recently released guest suggestion form. Go to securityweekly.com/guests and enter your suggestions. Security Weekly will be at Hacker Halted in Atlanta, Georgia this October 10th and 11th. EC Council is offering our listeners a 15% discount to sit for any of their bootcamp courses or workshops. Visit securityweekly.com/hackerhalted to register now. So, John, we just had a great conversation with Shannon about measuring things, securability in particular, about approaching DevSecOps. And looks like, speaking of measuring things, we have some interesting CVSS scores this week to talk about in bugs and breaches. We have a
there's also. I was just going to say, there's all sorts of good stuff in here. It's always a treat to sort of either watch Shannon on stage or read her blogs or her tweets. So it's great fun great to have her on. But yeah, let's dig through what we got going on in here for this week.
Yeah, I'll start off with one that is near and dear to my heart merely because I use VI all the time. And to put things in perspective from a threat model, there is basically a command execution where that could be performed against VI from a well-crafted text file, essentially, that's attacking VI's use of its mode line function, which originally mode line is really just designed to be able to have a text file self-declare that says, I want my tab stop to be here. I want my use 2 spaces or 4 spaces in a tab, things like that. But what's interesting about this is that a researcher found a way to break out of the sandboxing that's intended around this mode line functionality. So they're basically able to say, I'm going to use the vim source command to pull in another file that just so happens to execute a command of my desire. And in this case, a proof of concept is always a uname-a, just to dump the information about a system, or from a more useful perspective, sending off a reverse shell. So to me, that was kind of neat, but it wasn't a high risk. I don't think anybody's immediately in danger of being compromised by this type of vulnerability, but it does point out that idea of building sandboxes and building state machines in the sense of within your programs, in the sense of what am I parsing, what state am I in terms of parsing a mode line? Am I supposed to be in a restricted set of commands? Should I be opening it? So I kind of take that from a particular sort of lesson in how to approach and consider software, because there's a lot of risks that can come out with it.
I think it's everything you said, but it's also back to sort of security in depth, right? It's do you need to have an editor in some of these locations where someone might want to actually try to leverage this vulnerability? It's I personally fairly notoriously bad when I'm in the whole container world. I'll exec into a container. I'm trying to modify a bit of JavaScript or something, and you hit VI and it's not there. So okay, we can fix that easy, right? No problem. Apt update, get install Vim. Okay, well you just that seemed like a really great idea, but is that really something you want to do? And so this is sort of, and I suspect this is probably more someone, if you're thinking about your targets for this, maybe a developer and have them run something, be able to place something into some code before it gets committed. So I could see there's being some ways that this could be used. Um, but interesting, especially around the sandboxing part, right? Because that's just at that point, this is again back to thinking about how did this vulnerability get found, right? I haven't read all the details on it, but I'm guessing they didn't just go and accidentally, have a mode line which could do this. They were going about with power saying, hey, can I get an exploit through this? Let me grab the code. Let me start digging through it. Okay, how is the sandbox? Okay, how could I actually, take advantage of that? So, little good little bit of work on someone's part, but yeah, it's interesting to think about how do you do that? How do you defend against it? For people who are writing software, which might be doing some sort of input, taking input from users, this might be a good example of where to go and look and go. The nice thing about open source is, well, the bad thing is someone can look at the source and figure out that weakness. On the other hand, now you can go in there and probably fairly quickly see what was the patch that they've applied to actually make sure this doesn't happen again. So, yeah, it's a good, not just academic example, but hopefully it doesn't cause too much damage.
Yeah, hopefully. And I think you raise a great point too about um, you know, trying to debug something, debugging in production, or throwing something, throwing VI or some other, even a GDB onto a system. One of great design patterns that I would love to aspire to for many teams is that anytime a human touches a system that's in production, because often, maybe the application logging wasn't sufficient, they needed to for some reason, but a human touches the system, get the information, figure out the debug the problem, and then that system is killed and a new fresh one is spun up. That'd be a great pattern to avoid from a process and a operations pattern perspective this type of problem where there could be some pretty clever and interesting ways that it becomes a security vulnerability in the future.
It's, you know, I think we were starting to get some mature patterns around SSH logging or bash shell logging or those type of things with our pre-container days. Those were so long ago, but I'm not aware right now of too many people who are logging, say, events of every time an exec into a container happens. So something else to think about for people out there if they're going down that path. How would you do that in Kubernetes? How would you do that in Docker? Um, and let's be honest, if you're running some of this stuff in prod, you shouldn't be allowing that container to be able to go out and access well, even container, not virtual machine, hell, even your big iron shouldn't just be given a route back out to the internet to go and start downloading packages. So again, defense in depth. How do you take care of these things and minimize the chance of it happening?
Yeah, you bet that egress filtering is awesome. And even if that was we talked last week about the XIM vulnerability that was in exec VE. So if you're logging that, that would be interesting just to see. Hopefully, you would have caught it if you're running those vulnerable versions and you're seeing signs of exploitation. So it's a lot of fun things we can learn about a simple VI, which I'm going to put it out there as one of the best. I'll throw out all my superlatives in terms of text editors. But before we go too far down that path and we get too much feedback on that, let's dive into some other angles. One I wanted to call out was just another example of a Chrome extension that is introducing, what's typically called universal XSS. So the Evernote web clipper for Chrome was using the post message API, so standard W3C API, to call back and forth to basically figure out what is a URL that it wants to clip from. And what a researcher was able to figure out is that here is a Chrome extension that has a high amount of privilege, meaning if it's going to basically take clips of a web page, it needs to be able to read that web page. So it's basically an extension that by design is weakening that same origin policy. And when it works great. When there are flaws, then it is a bit worrisome because that opens up this idea of XSS everywhere, potentially.
Yeah, that's I didn't look at this guy closely, but it's yeah, it's cross-site scripting is still around.
Yeah, that's
I mean, the result of what you're talking about is more interesting in how they actually found and protected it, but still, cross-site scripting is still around.
Yeah, cross-site scripting is still around, but I think what I'd prefer to highlight from that instance is some cool work out of Duo Labs that was, I think this is about 2 months old now, but they did the crexcavator.io, which is basically a way to generate a risk baseline for Chrome extensions. So just like we were talking with Shannon about, how do you measure something, and measuring things are very important. Duo Labs with their CR Excavator basically said, here is a way to pull some dimensions of interest about a particular Chrome extension, whether it is asking for heavy privileges, it's able to read and write to cookies, or whether it falls into particular, how hardened does its manifest look like, things like that. So that's the aspect actually that I think was more interesting here, not the specific extension itself, but how do you, use a tool like that, CR Excavator, to go and monitor them.
And this, I think I agree with you, is actually really interesting. And we're seeing this continuing pattern, right, of more real sort of purpose-driven or purpose-built scanners. So instead of having that general, the Fortifys of the world, have something that's looking more, maybe not quite as much of a depth of that static analysis, but being able to say, hey, here's something you've got a problem with, or you might want to have a better understanding of the security nature of it. Run it through this tool and see what it looks like. And yeah, I think those are really great things to have.
Yeah, and I think if we were talking about cross-site scripting that's been around forever, there's another rumblings and grumblings of insecurity around BGP that I think has been around forever. This is an item you highlighted, John.
Yeah. And this is so, one of my previous lives is doing internet infrastructure, either data center routing or things like that. And for those who don't know, quick recap on so BGP, Border Gateway Protocol. This is basically the routing protocol which runs the internet. This is a really huge table. I think we're up to about 36 to 40 megabytes in size of a routing table. That basically your core routers take this thing to understand how an IP address gets from within your ISP out across the internet, who it needs to talk to, and get to the other end. And it has costing and different sort of capabilities in there to understand or to allow those calculations to happen. There's ways to secure BGP. Companies have gotten much better at doing that over the last 10, 15 years, but there's still occasionally weaknesses. And, it's someone did I think it was one of the Loft guys did a talk to Congress probably about 10 or 15 years ago, basically saying, if we went and did this, we could probably control the whole internet in about a few hours. And this happened with parts of Europe recently, where most of the people who are running BGP routers now, they know you don't just take a 0/0 or basically a default route from someone else's BGP advertisement, but every now and then you find a weakness and you're able to get that through. And good old China Telecom decided to announce a default route on BGP, and it was probably a little targeted, but it picked up mobile browser traffic or mobile device traffic in Europe for about 2 hours. So that's not what we're talking about here, right? We're here about application security weekly, not internet or infrastructure security weekly. By the way, that's coming up pretty soon. But what's actually interesting here is, when we go out and talk to people about why you need to have crypto or why you need to secure your not just the application itself, but the transmission of data between 2 points, people are like, oh, man-in-the-middle attacks are really hard to do, or someone would have to be really coming after me in particular to do a man-in-the-middle attack, or all these sort of reasons. If someone is interested enough in you, say the Chinese government, and this wasn't the first time China Telecom did this, right? So they're known for doing this type of thing. You need to have those pieces in place. You have to expect that, your self-signed certificate is useless. You need to have decent TLS. You need to have, preferably, if you're doing something sensitive, mutual TLS. So there's all these type of things where people actually need to consider that just because I'm coming off my mobile device and it's a secure signal up to an LTE tower, there's still going to be weaknesses in there. So again, back to I keep saying the same thing about defense in depth. You have to think about these type of things when you're running an application with data.
Yeah, that's a great point. And that part about tying it back into application security is pretty good in the sense of making sure, HSTS, making sure you're actually using mutual TLS ideally, or at least TLS that is stacks that will resist a downgrade attack, or even
Mhm.
on lots of mobile apps, certificate pinning. That's one of the other fantastic ways of defeating these types of intermediation attacks against clients. So it's not so much you have to be worried about your local cafe or even maybe your airport Wi-Fi. There could be even plenty of things that are going on behind the scenes at the lower, internet routing layer that you're just blind to from the client perspective. I will
Yeah.
throw out
The
too. Yeah, go ahead.
Keep
Real
going.
quick, you mentioned that Loft. That was way back in May 1998. So that testimony was that was a good 21 years ago now, and they're still talking about very very similar types of critical infrastructure issues.
Yeah, it's we've improved. I think back then probably nobody was doing BGP auth or MD5 sums on there. So things have gotten better, but still far from perfect.
Still far from perfect. Yeah, we'll check in at episode 100 maybe just to see what that number brings us. Um, Talking about things that are still pretty bad, there's another vulnerability you were highlighting from some um, medical device with a CVSS rating flaw that associated of 10.
Yeah, this was a fun one. And by which I mean it's not fun at all, but scary as all get out. So, yeah, let me actually pull this one up. A company called well, who cares what their name is? Well, of course we care what their name is. They've got a medical device, which is it's what's referred to as a medical infusion pump. So if you've ever been in the hospital, usually ICU, and you see these big, crazy syringes that have a motor on them, slowly pushing a drug down into someone's IV. Every time I've only seen them a few times, but still, like I don't like needles, I don't like syringes, and these things are big needles or big syringes, and yeah, it's bad for me. But so anyways, a vulnerability was found a few weeks ago. Two vulnerabilities, one so-so, one less. But end of the day, these in certain hospitals or certain of these medical devices, um, they actually have the ability to wirelessly connect out to a central gateway, right? So a nursing station probably or something like that, where they could go through and modify your the level of infusion. So how many milligrams or micrograms are you adding per hour into a line? Turns out there's no authentication or there's really bad authentication. So you can quickly guess where one use case of this would be, where you have the ability to go in and actually modify, either turn on or turn down or turn up what that infusion rate is. Hospitals usually that type of thing is something you might want to be sort of sensitive to, and so yeah, that's not really the best situation to have set up. There was a second one in there where if you're really outgoing and in the mood, you could actually upload firmware, and at that point, um, you would have the ability to brick not so much the end device with that syringe thing on it, but to brick the controller, the central gateway. Um, and yeah, that's again usually considered not good, especially in hospitals. But what I thought was interesting about this was two things. One, Homeland Security in the U.S., our CERT team now has what are they referring to themselves as, a industrial control system unit. So they've seen enough of these type of ICS type events, like one of your other items in here you'll probably talk about, Mike, that they've actually got a separate team that's now doing research and disclosure on these type of things. So yeah, they listed this as a CVSS 10 on V3, one of the two. That's the first one, I believe. And what was interesting to me about this was, okay, that makes sense. If you have the IP address of where the thing is and you're able to access it, and the authentication isn't that great, that's a 10. Executive from that company was asked through the media what they thought about this. Their response was, "Oh, no, 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 no! It's really not that bad. You'd have to have an understanding of the hospital and how our devices work, and what IP addresses had and things like this, and very difficult to. It's definitely not that simple to do. And by the way, we don't use these in the U.S." So what I was thinking is it'd be really interesting to see some sort of a metric out there that is a ratio between a published CVSS score from a reputable industry, a reputable group, whether that's government or private, and compare that to what an executive of that firm claims the chance of their device getting compromised is. And I think that would be really handy for people to have a solid understanding of, can you trust the company that you're working with? It's one thing, I think, in many cases to sort of, go gray line and say, hey, this isn't that bad, or certain ways we can mitigate or things like that. But at the same time, I think when you've got someone that's, I don't want to put words into anyone's mouth or say something, that could be quoted on here, but something which looks like it's really bad and have someone say, oh, no, really, that's not that bad at all. I think that's something for people to consider when they purchase products, whether that's a security product or a healthcare product or all these type of things. So it raised my hackles a little bit, yes.
Yeah, that's interesting because it's not so much a disclosure timeline issue in terms of time to fix, but it's sort of a metric you're kind of riffing on here in the sense of the ratio of reality to diminishing the problem, devaluing the problem. That I would be very curious to dive into that and play around with some of the data just to kind of see what comes out of that in the sense of here are the anti-patterns of how not to respond to a disclosure or evaluate, talking about whether IP addresses or understanding some of the basics of a hospital is, an Nmap away, or literally just wait for somebody to write the Metasploit module and go forth and conquer. So yeah, very interesting points there. I think this also was making me think of, at a more general case, the IamTheCavalry.org. That's a security industry group that has been looking at a lot of medical devices as well as some automotive devices as well. But they've been looking at these from the angle of saying somebody needs to be paying attention to the security, and this ties into safety. For very much as avoiding to talk too much about these massive needles so we don't get too squeamish here, because we don't need to, because those are pretty scary. But those have a very clear and direct, physical impact on people if they are misused, abused, or even if it's just a matter of here is the rampant ransomware that is the next WannaCry that isn't necessarily even targeting the functionality of a device, but here's an open device whose firmware can be overwritten, modified, and essentially just bricked for whatever reason. What I'll do is turn us now to fuzzing for flaws in HSMs. So this was another vulnerability that, much like industrial control systems, are pretty critical to infrastructure. HSMs are a pretty critical component of a lot of DevSecOps deployments, whether that's where the secrets are stored. That's where, when we talk about service mutual TLS or service to service authentication, these hardware security modules are where the vulnerabilities are stored, but also where intentionally the secrets are stored. And in this case, it was a group was looking at one of these HSMs, and they saw that the firmware was signed, but not encrypted. And so the signing of the firmware means that they wouldn't be able to tamper with it. But because it wasn't encrypted, they could inspect it. And lo and behold, in that inspection, they found essentially some classic buffer overflows and in the PKCS11 API, which for those of you out there who have maybe not heard of PKCS11 too much, but it and ASN.1 are notorious parsing parsers that are notoriously insecure, because it's really hard to get parsing right in a language like C, because it becomes very complex. You're doing a lot of arithmetic, also often a lot of pointer arithmetic to try to do things quickly and efficiently, but losing the forest for the trees, so to speak, and then introducing vulnerabilities. So, John,
was
I don't
interesting.
know. Yeah.
It was interesting from the point of view of folks who either purchase or use HSMs. They're not doing it for the hell of it, right? These things aren't cheap.
Right.
I forget the quote, and so the version which I'll have to qualify myself here. The version which are being used at Amazon, that's where I'm going with the story. They are not the ones which are vulnerable. The ones which are vulnerable, it's out there on the internet. But at Amazon, those bad boys are a pretty penny on a monthly basis. So and usually if you're using a HSM, you want to use two of them because you ain't going to have that type of thing fail over and die because that's where your crypto keys are. So a lot of money being spent on these. Um, Obviously, to store secure, really sensitive information. Someone trying to do security right. So to find a weakness in a device like that is either a gold mine or extremely unfortunate, depending on whose point of view you have.
Yeah, exactly. And it's one of those things that, maybe it's talking about like the fuzzing and access, and from a researcher and vulnerability research point of view, they're also not easily come by because they are so expensive. So it's one of those things that perhaps there is a little bit of a not castles built on sand, but there's possibly some creakiness and some brittleness to them, just because not as many eyes have been had a chance to play with them.
And I think the blog post mentioned, I was reading this like last week when it came out. So that was about, before a 17-hour plane ride. Still awake. But I don't think they bought this, right? I think they either found this somewhere or they got access to it. So again, yeah, that it's nice to try and set artificial levels of access, things like this. But yeah, people find a way.
Yeah. People find a way, and especially, I guess, I'll throw out the public service announcement. If you are selling your old networking or hard drives equipment on eBay, make sure you wipe them, because that's an easy way to find hard-coded secrets, to find sensitive configuration files for all kinds of well-known companies. So, yeah, trolling eBay is a great vulnerability mechanism.
And if somebody's looking for better ways to take care of their data, I've got photos out on the internet. I usually do one every few years. Every time I destroy another hard drive with a hammer and a screwdriver, I usually take artistic photos and put them out there. So that's how you do that stuff right. You don't sell your drives on eBay.
Yeah. Now, John, there's another item I wanted to call out as a point of interest, and as a positive shout out for, wait for it, machine learning. I was at a hardware.io conference last week, and really interesting. It's hardwear.io. And this was their first time in the US, and they've been doing it in the Netherlands for a handful of years now. And the gist of it is focusing and looking at hardware security problems, which to a great degree are pretty much software problems, just harder to fix because you actually have, physical chips, silicon that has now isn't as easy to go and update over time. So, but one of the things that they came across that I saw there was a timing analysis. So we've talked about side channels and timing analysis on a bunch of different episodes, but in this case, I was pointing to a particular blog post that was demonstrating how to use math and Gaussian mixture models to basically improve the detectability and or I should say, perhaps the precision and accuracy available for a timing channel attack. So I wanted to throw that out there in the sense that math and InfoSec and application security can go hand in hand very well. And we don't always have to be hand wavy when we're talking about machine learning. So there's good stuff out there.
So there's this is a really fun blog post to read. So from my point of view, the math around ML it varies in complexity. I think honestly some of the little Greek characters are worse than the actual math itself. But what this paper did, or this blog post did, what I thought was interesting is showing the distribution curves, right? And actually there's one in there where it shows the spike bell curve of noise, and then off to the right is, okay, it's a much lower one, but that's actually what you want to focus on. I think for a lot of us who are visual based, that helps get an understanding of what some of this machine learning stuff is about, right? So it's most ML to some degree, unless you go highly multivariate, can be boiled down into something which can be made visual through a two-space or three-space graph. And I think that then for a lot of us starts getting an understanding of what's that math trying to do, or what is the machine learning inside trying to do. So I thought that was really interesting around this.
Yeah, it's that good idea of just saying, we are, for as much as we're struggling to find metrics like securability and well-defined metrics around risk and impact and likelihood, there's also a lot of other grounded math looking at distributions, of approaching different problems. And it's great to bring in engineering disciplines, math disciplines into application security to basically go beyond those, quote unquote, smart if statements into something that actually works and reveals good information.
And I suspect for some of our listeners, those who are, into this type of thing are looking for a project, go back and think about the last segment when we were talking to Shannon about um, how do you deal with these large volumes of data, or how do you actually find that signal to noise? And, you know, this there's some good uses for machine learning in that shifting left concept, and this will sort of help, if you're looking for something to work on. It could be a few interesting projects here.
Yeah, I think in terms of interesting projects, one of the last article that I pulled out here was from a Microsoft security blog, and just kind of pulling out 4 best practices. And so again, these perhaps aren't earth-shattering, but they're, I think, a good reinforcement of what, when we talk about DevSecOps, it would also be helpful to have a little bit of a working definition or good references to what we're actually talking about. And so for as much as you were just saying now, collecting lots of data and how to go into that data, actually find, what's interesting or what's a signal that's either as a security event, a security alert. Just that fact of collecting your cloud resources, meaning not only what are your Lambda functions, what are your containers, but what are all of your users, what are all of the roles and RBAC that they have associated with them. That gets to be really complex, and one person can't just put that in their mind and keep it straight. So that's step one that I thought was just easy to say, hard to do. And a couple
I
other.
guess,
Mhm.
and I hear where you're coming from, and I think you're right. And I think this is one of those cases where, as someone who practices this stuff, day in, day out to a large degree, I intrigued by the headline. I was let down by their 4 points. And I think actually the opening paragraph was had some really great stuff in it. But I think you're right. I think, that sort of, it allows you to level set and sort of figure out what are some of these basic things. And it does sound simple. I mean, think about uh I'll say it this way. For a period of time, at some point in the past, I had an employee who would like to do his R&D in different regions of AWS around the world, when the rest of the team was doing it in a particular region. And then that employee and his employer parted ways, and it took us a while of, browsing around, going, oh, Singapore. Never would have thought running a server there. Let's shut that one down too. So yeah, it's, and that stuff can be relatively difficult to track down. So yeah, there is value in this point. It is worth sort of thinking about for a few minutes reading that blog post. It's funny, we've been doing a lot of bits about Microsoft recently, but we're not getting paid by them. They're just doing a bunch of good stuff.
I know. So yeah, please come on and have some sponsor us, because you're doing some good stuff. And I will say too, to that point, that for as much as it's easy to say, hard to do, I was really wishing it wasn't so hard, because all of these cloud providers, when it comes to billing, they're pretty good at sending you that bill, and that bill can also be very surprising if you haven't been paying attention to your CPU utilization or your storage. But just being able to bill for something means you are able to measure that here is a function running, here is these number of instances running, these number of containers running. So there is at least some way to enumerate them. Obviously, it may not be as user friendly, so that's possibly the part where we're falling down on. But I want to say that something like cloud environments should also almost be getting us closer to perfect information about our environment, as opposed to the data centers where it was who knows what was spinning up what services where and when and for how long. So maybe I'm going to throw that out there as my optimism for the day.
There's some good stuff out there. It's Netflix. I think they somewhat forked it. It was called ICE, I believe. So it was specific to Amazon. You'd give it access to your account. It would go through, grab all the data, and it'd give you, again, as I said, I'm a visual person. It would give you a graph broken down by the different services and how much was being used of each. So the tools exist out there. I think it comes down to um, you know getting burned once or twice, unfortunately, right now, and realizing, oh, I need to keep track of this stuff. So maybe I think the big thing for those guys is how can they make it um, easier up front. You don't need to have the if you've ever tried to load a 30 megabyte CSV from your Amazon bill into Excel to do some work on it, there's probably better ways that they could do to get that data to us.
That is a good point. Um, any parting thoughts for the day, John, or any hints of where you may be next week when we see you again?
I know, right? It's like I'm the traveling show. I'm at home 1 week this month. Next week I'm in Amazon. Oh my God, I always forget the name.
Oh,
Reinvent.
I think this one's Reinforce, the security
Thank you,
one.
Reinforce. Like
Yes.
my coworker's been making fun of me for months, so I'll be back in Boston next week for that. Looking forward to a good time and talking security with cloud folks.
Awesome. Well, definitely say hi to Shannon for us, and we're also going to keep an eye out, Shannon, for the work on securability you're doing, and especially on that paper that's coming out soon. And thanks everyone else for joining us again this week. We'll see you next week on Application Security Weekly.